Hi everyone. So today we're gonna see how to set up this UPI installation in this KPM machine. So we already seen how to set up the TNS server, and today we're gonna see how to set up Bayesian host. And in the Bayesian host, we're gonna set up load balancer and HTTPD server to share like file transfer server. So FTP, that's it. HTTPD and bootstrap, master node, worker node. So we already set up the DNS server, and we're going to set up this Bayesian host, bootstrap, master node, worker node. So these at all we're going to set up. So as I already, we're going to set up in the Bayesian host itself, HAProxy, HTTP servers. So both we're going to set up. And for this itself, we're going to use 2 cores. For DNS, we already used 1 core. So for RAM, we don't have any challenge, but for the cores, we have huge challenge. And for this isn't a smooth setup, which I'm using right now. For bootstrap, we required, yes, we required 4 cores. And for master node also, we required, we want to give 4 cores. Go for 4 cores. And that is also, so we are adding any another infra node or worker node more than this, and we want to add, or we're gonna remove the bootstrap however in the end of the installation. So we can see here, first we want to install ISO files. That means we want to download ISO and ignition files and OpenShift client, OpenShift Linux files, that we use that to generate the ignition files for bootstrap, master and worker. So those what we want to make them, and we want to make them as a ignition files. Once done, we will keep that as a in the file transfer server, and we want to set up the replica to 0 everything. So we want to check the master scheduler parameter. Yeah, we can check that in this directory, so it will available that we want to set up this to replica. Master will always by default it will be true to schedule the paths, but we want to make it false. Once we made it to false, then none of the paths can be scheduled there, and everything is ready to install. Ignite the ignition files. All right, okay, we will go into the UPI installation setup. First we will Bayesian host. Okay, how are we going to set up? We will install the Bayesian node, the IP6. Okay, so these things everything we can copy paste, either we can manually set up that IP. So this everything will be static. So first we will set up the IP, and second we're going to set up the HAProxy load balancer and configure the HAProxy, reboot them, and we will whitelist the ports in the firewall and AC Linux port configuration. We will check the connectivity. All right, we will start the services and we will check the connectivities. All right, so that's what here we can see. Okay guys, we can initiate the installation. We have set up the HTTPD server here. Yes, we need to install the HTTPD server as 6 install, and we can start it. So first we will start the DNS server, and we're going to set up the browse where we have this CentOS 9 forward. We give 2048 2 GB RAM and 2 cores, so that's enough. Forward 20, yeah, it's 20 is enough, and we will give bash sufficient. Bridge, yeah, it's already in bridge. We'll use minimum installation network. So this is mandatory, so we will configure this. IPv4 manual add 192.168.0.55.2 gateway, right? Sorry. So 6 we will disable it. Save. Right, we can save this and we can apply Bayesian here. Play. And we give done. Okay, we can begin the installation. Alright, we will reboot. So we give name and password, and we can set up new TUI edit connection, and right, everything is there. Okay, possibly we could be able to take. Okay, this is, we will install all the support files. So we have set up all the IP, static IP we have given to 6, and now we're going to install this. Okay, it got completed. Now we go for Bayesian host setup. So now we will install the HAProxy. So this is quick process, so it won't consume that much time, and we will move to directory. So this is nothing, we just taking the original config file, HAProxy file as a backup, and we creating config file again. Okay, so first we will move this. Okay, we moved. We edit now. We are editing this now. We are in insert mode. I think I will have some challenges with this VI edit. Okay, first we will copy paste. So I already given this all the configurations, like I already set up the server for Bootstrap IP and the port number 22623. So this is the port number for Bootstrap or either master node. But for the worker node, it's in a 443. So that's a regular HTTP. So this is the API server IP, sorry, port number. Right, we're gonna save this and we will reboot it. System is rebooting. So now we want to understand in organization at all, there will be a different setup. For example, DNS server will be in different network, and we will have the different network which we are deploying our cluster. So we ensure with the network team or with the configurations connectivity is there or not. So now we can check it's came back. Stop the firewall first. So I think we don't want to get into trouble with this port conflicts. So we simply disable and we stop that. Okay, first we will stop the firewall, restart the HA proxies. Okay, sudo. And now, so we need to configure this port HA proxy, all which are mentioned that 443 and 22623. This ports should be always permitted in SE Linux. So it should not be restrict any ports which are used by HA proxy, right? And similar with the FTP server also between communications. Okay, we'll set permanent connectivity. Okay, this is not because we didn't install the HTTP server yet, so we'll install that. Okay, now we will restart the services. We'll check the status HTTPD server right now. So we want to allow to listen in port number 80. So that also we want to configure. So now it got installed. Modify that. So here we can see listen port, it's 80. So listen port should be now it's 80. Yes. Now I try to save. Gonna save. Okay. The server gonna listen 80. Next we will enable and we can start it. Okay. Everything is now Apache server got started in port 80. All right. So everything is done now. So we will heading to this UPI installation now. Okay, guys. So this firewall port adding everything at all not required because we have disabled it here as this is a lab. So okay, first thing we will generate the SSH key. Create first the directories keygen. So we will give, so this is the root. Okay, we have created this successfully. Next, so now we want to mirror this. Before I want to show you this, you can copy paste this in browser. Okay, here you can see 4.18.23. This is what I'm gonna install. Click over, this is the file on GP, which is 2025 they have released. We can directly use this to pull in the terminal. Okay, we paste it here. We're gonna download this. Okay, next we will see the installer files. We can pick it using this link. So this is 20. I think we require 23. So this inside this we can see this 23. Here OCP. So here we can see client for AMD client. Yes, this is what. So you want to pull that. We get this. We will mirror it. We will download. And last you can see it's in a client CLI version. This is also similar, you can check and download. So once done, so when you are seeing these steps, it seems very complicated until you understand those things. So these still now you could see these are very this step seems like what is this, why we going the site and why we are configuring these things, kind of things you can think yourself. But you know, when you started practicing this is enough 5 to 10 minutes steps to configure load balancer or Bayesian host setup or whatever the first time. So once you do yourself, and this is in a very easy method actually. So it's initial time, the understanding is everything. So compound by compound you should understand. So it will take it will take a month over a year to completely understand this OpenShift. Once you understand, the installation is very simple. Within this home lab itself, you can take two or two setup. That's it. It's not that complicated. If you are familiar with the networking and this containerization and understanding with this Kubernetes, it's very easy. So you should understand OpenShift in that aspects. What were things? So there's 280, 380, 322, 316 ODF and virtualization, and 267. It's not mandatory, but you require to understand ODF and virtualization. Nowadays it's trending. You should have knowledge. So day by day the organizations are adopting for visualizations. So in that aspects we should definitely aware minimum of the visualization. That's what I can say. Okay, now we have downloaded everything, so we have set it up. Okay, we'll check it this. Okay, here we will go for what dot 18 dot 1718.23, and here it is. So we record this one, copy link address, and we will present it here, wget. Okay, all right, we will use this to install. Okay, we will remove before uh, okay, now we can unzip it. Yes. Okay, now we can move OC and kubelet to bin. Okay, now we can type OC not found. All right, we will export that. Okay, now we can try. Yes. Okay, we will make it permanent to access. All right, so everything is in set. We can good to go. So this is Bayesian host. We have set it up now. We already set it up this HA proxy, and we set it up the HTTPD file transfer also. And now we're gonna head into ignitions. Okay, so we will open the OpenShift install. So we will initiate that to generate the ignition files. Okay, so we can make directory mk OCP installation. Okay, we will get into this. No, nothing will be okay. There we can create the install config.yaml. So this everything will be in the official document. So we will write it here and we'll save it. Okay, fine. Now we want to next we want to create this manifest file we already created, and what we want to create. So ignition configs we want to create. So what is inside this installer? Yes, manifest files are there. Using that, we want to create the ignition files. Okay, let it take time. Okay, all right, fine. So /auth here is the authentication and configuration files. Let we check this install and tab. Yes, see, look at here. So for creating the cluster, we record bootstrap ignition file. After that, we don't record this, and then on for every time we want to create the master node, we record this ignition files. So after installing, if we missed this master also, we can create with the machine config um, operator and worker ignition. So these files we want to use these ignition files, then only we can create the nodes. All right, fine. And so here is the authentication directory. So what is there? We could explore. So here we can see the kubeconfig file and the kubeadmin password file. All right. So these are very important files for this cluster. These are the login credentials. All right, fine. Okay. We will get the ignitions. Okay, before that, we will copy this to share the HTTP. So there we want to just copy them. So CD to OCP installer. All right. And here we want to copy all this to HTTP. Yes. Yes. There are already several files will be there. So now we can see where the HTML. Here we can see. All right. So everything is there. Okay, we will test. So everything is there, right? So now we will test whether we can accessible or not. All right, we can able to access the files. Okay, so now, all right. So now what we're gonna do? So we're gonna create the master node, and we will start the ignitions. Okay, forward, and we select this master. I don't want to do anything here because these are essential. Okay, and here we go. We can see 4.18.23. Yes, choose the volume and remove the automatic, and we give the generate. Right, forward, and we give 16,473 something almost, and 5. So for bootstrap, not active dismiss, but however we will assign some and we will dismantle that. You bootstrap. Okay, so this is This is happening. And now what we want to do, UI, so I want to edit the connection. I want to give the IP, what we require. So we want to give manual and show address 192.168.0 dot. So for this bootstrap, we will give 9 because we will dismiss this. We don't require any sequence with this. Gateway is 1, and what else we require? So we require DNS server. So we have the internal DNS. So we give this 0.5. This is DNS server. So here we can disable it, and finally we can give OK, and we can go back, and we can give. I don't know why it's not moving. Yes, great. And Control L, and now we can sudo CoreOS installer install directory VDA. Yes, and ignition URL equals http colon 192.168.0.6 colon 8080 port number and slash bootstrap dot ignish. All right, and now unsecure ignition, I can mention it, and copy hyphen network. All right, we can give something wrong. I didn't expect it insecure. It should be insecure, not an unsecure. Should be 100% correct, but it happens. All right, it's happening. So here is the command. With this, we can check what is the progress of this. We are not. We can go outside of this directory and we can give arrow. See, right now it couldn't be able to communicate with Kubelet API because our, yeah. So we will reboot it and it will start to pull all the ignitions. All right. So there is no errors and it could pull the bootstrap name as a host name and ignition. User provide config was applied. Everything is perfect, and we could see here what is the update. So nothing is there. All right. Okay. So now we will do SSH to the bootstrap and we'll check it. What is the status right now? Yes, we could be able to log in and we can check live. Just update, any error is going on. It could be able to communicate. Yes, it can able to communicate with the internet through the internal DNS server. So we don't have any issue right now. All right. So where it's being now, so it could unroutable table filtering API automatically. Okay, these are common, so we don't have any issues right now because it could be able to create all the necessary YAMLs also, and it's in progress right now. So what it's happening right now? So rendering kube API server core manifest. Okay, all right. So it will ignite the core ignition, and we will get the. Okay, we'll open the. We'll log in into the Bayesian host, and here we can check. So yes, Jai. So we don't want to do anything. So we just. Okay, not this. Okay, we'll run this and we are not there. So slash root. Okay, we'll run this. Check what is the status of the API server. So the bootstrap should provision the API server, and we could get the events here. So it won't be challenged now. So it's rendering, and we can start the master node also. So its ignition is happening, and we should create the master node as well. All right, we will create the master node and it will provision into the master node. All right, so same one, and this time generate forward, and we should give 16 gig, and we'll give 5 cores and 100 gig storage, and we'll give master 01. Networking is bridge network. I already configured it. Let's start to create. Yes, it's happening. So now we will give the same. So nmtui. So we'll configure the static IP. This is the procedure. Manual, we'll give it show add address 192.168.0.7. Gateway should be 0.5. No, it's in 1. and here gateway should be DNS IP should be 5. It's an internal IP. We'll go for IPv6 and so we'll give it it's in automatic, and now we will disable it. All right, give OK, and we'll give back, quiet, and control N. Now sudo. So now we'll install the core installer install dev/vda. All right, here it will pick the ignition pipe, and we will give ignition URL equals http://192.168.0.6 and :8080. So here is the shared file, shared server. So it's master ignition, and now insecure ignition. Fine. Copy from the network. So, all right. So this is very simple. So we're getting events. So what is happening? So yeah. So failed to. Oh, this is normal only. Okay, couldn't get any events. That's fine. Okay. Yes, it could be able to pull, and now we can ignite this master node, and so this is master node. So here we already DNS is there, Bayesian host, master 1 is there, and bootstrap is already booting. And once it's done and when it's stabilized, and master node will get the communication with the bootstrap, and all the static pods will up and running. All the static API server, scheduler server, controller, control manager, and etcd. So it's a major one. Everything will be up and running. So once the bootstrap establishes the communication with the master node, all right. So until it will show the jobs are failed because API internal part is not available because of the API server is not available in the bootstrap, right? So once this is rectified, and master node will come up. Bootstrap, it will take minimum 20 minutes. That is what it's saying. You can see the time. So it will take another 10 minutes. Okay, guys. So this been created everything. So API server is in ready state and waiting for bootstrap etc member to be removed. It's removed safely. So now we can remove the bootstrap node. Okay, here we can see bootstrap is not at all progressing anything. So master node everything is handling the rest of process everything. So let me check the bootstrap. So here we can see the bootstrap all plus etcd, bootstrap successful, and etcd also successful. And here the last logs are very important. URL also reachable, and so the endpoint is also ready. Bootstrap service is completed and it's deactivated itself. All right, that's it, guys. So we can delete this bootstrap. We can go here and we can stop. Okay, we can delete it. Okay, now master one is there. So that's it. So now we can export auth directly. So now we can get OC cluster version. Yes, so okay, connected. So cluster operators, and so everything is in good shape. What is this console? We can ignore this. So this is not such important. And now the master node is there. With this combined, we will install 2 more master nodes. So we will use that master node as a master and worker as well. So even we will install the storage also. So we will use this compo cluster. Okay, so we can see already here master, worker, everything. So we can make it only control plane, and we can remove this worker combined workloads. Like we can remove this spec also, but we don't want to do that because our lab is very simple. So this is not such system monitoring. So we don't have huge number of resources. So we have only 20 CPUs. So already for master node we have given 5 CPUs. For example, host already will take minimum 4, I think. The remaining we already given master node 5. So we will utilize another 2 more master nodes. So we will use this as a compo cluster. Okay. So again we have prepared for master 2, and so I can say sudo core os I can install from dev/vda ignition equals http://192.168.0.6 and :8080, and so what will be the file? Master.ignition. Right. Again, we require to install this worker, so we simply want to give the worker.ignition. That's it, simple. So we're giving master only. There is no master 1, master 2, master 3 ignition. Same ignition file, and it should be in secure ignition, and copy from network. Right, there should be no mistake. That's it's firing now. All right. So meanwhile, we will create one more master. So browse it. So same generic forward 16 743 and should be 5. It will be too much load to my system now. Master 03 finish. All right, we will initiate this. Where is this cursor? No, not 6. Okay, it will automatically start to boot and join with the cluster now. So we don't want to worry about master 2. So we will configure the master UI. All right, what we see? User provided config was already. Master 2 host already exported from ignition. All right. Now here we will give IP address. Yes. In my router, in my home router, I have already kept a static IPs. So I'm just automatically assigning. So you want to prepare some static IPs. Assign, or rather it will be very challenging every time if you connect to a mobile or laptop something, automatically IP will change. It won't be static. Okay, 11, we have, so it should be 0.11, 192.168.0.1, DNS 192.168.0.5. All right, everything is fine. Disable. Okay. Back and control it, and now we will give our magic commands. Install ignition, where it's from install, there's last video, and ignition URL equals http colon and 192.68.0.6 colon 8080 / master ignition, and what else? Insecure hyphen ignition. Okay, we can see that multiple times the master 2 is restarting. Some progress we could see. Copy from network. All right, yes, it's happening. And probably it's going well. Let me check here. Also get yellow. So this is master 2, and where is the master 1? Master 3, 2, 3, isn't it? Yes. Oh, now we will initiate this. Okay, there is only one master 1. Okay, let me check. Also get CSR. It should show all the pending requests. If any node is trying to bind with the cluster, so here we can see anything is pending, everything is up to. So there is only one pending, client kubelet. We will filter it. If any pending is there, we should see a lot of pendings. So everything is master 1 number. Mission config from bootstrap, so this everything will be go off. Yeah, so this is bootstrap 1. So we should wait for a couple more minutes. So master 3 is igniting, right? And what about master 2? This is master 1, so we don't require any master 1 anymore. Close it. There is master 2, yes, here it is. So one by one, those will, okay, it's initiating the kubelet. Okay, so here what we are trying to do, so once these nodes are came, and this is the way we can add the worker also. So I already shown how to provide that worker. So you need to prepare the same, we want to prepare the IPs, you want to add in the DNS server as records, and in load balancer also for master nodes, you need to provide. And once everything is fine, and you can create in the same way VMs. And here in this lab, what we're going to do, we will use 3 master nodes as a combo. That means each master node will work as a worker node also. We are going to assign that scheduling equal to true. So whatever you deploying, everything will be deploying the master node as well. That means we are not dedicatedly using any worker node for storage, for infra, whatever. Assuming this master is also as a worker. So here you can see control plane, master worker. So we're using as a worker also. So, because we don't have huge resources here, so as you can see, so already a system consuming 4 CPUs, and I given 5 CPUs for the master one, and so master 2 I given 5 CPUs. Now master 3 also I given 5 CPUs. Memory, we have a bunch of memories, so here there is no shortage. But when we going to practice for ODF for storage, any kind of operators virtual machines, so those will consume a number of cores. So here cores are the shortage. We don't have shortage with memory or storage. The shortage will be with only cores. So that's why I'm keeping that as a main point and concern. So I'm preferring it should be a very less consumption. Therefore, we going with only 3 nodes. All right. Okay, let me prove them. So it will approve the remaining everything. Let me see. Master 2. Alright guys, here we can see the nodes are up now. Let me check any pending, because if any pending and node will still in not ready state. Okay, you want to approve them. Node 2 and 3, these are the major things. So guys, let me approve them. So my host able to ping all the servers, so probably we can able to access them also. Things approved now. So all the nodes will be up now. Still not ready state. Everything is pending. Then why everything is in not ready state? So everything is in ready state now. Okay guys, that's it. This is how we can install this cluster.